What specific problem does the openthoughts project aim to solve in the context of reasoning-based domains, and how does it address this challenge?
The openthoughts project aims to solve the challenge of effectively curating high-quality supervised fine-tuning (SFT) datasets for reasoning-based domains, which is crucial for building strong reasoning models. It addresses this challenge by systematically exploring the design space of SFT data curation, focusing on identifying the best questions and corresponding answers that enhance reasoning capabilities. Through extensive empirical investigations, including over 1,000 ablation experiments across math, code, and science domains, the project develops a scalable pipeline that produces the openthoughts 3:1 2M dataset. This dataset demonstrates significant performance improvements, as evidenced by the resulting OpenThinker 3-7B model outperforming existing models on various reasoning benchmarks. By sharing their findings and models with the community, openthoughts seeks to demystify the data curation process and provide insights that can lead to better reasoning model development.
How does the proposed method of data curation work? Please illustrate the process step by step, detailing each phase of the data generation pipeline used in openthoughts 3:1.2M.
The data curation process for openthoughts 3:1.2M involves several systematic steps aimed at generating high-quality question-response pairs for reasoning. First, the pipeline begins with question sourcing, where questions are gathered from various sources categorized as fully synthetic, semi-synthetic, and non-synthetic, utilizing models like GPT-4o Mini and DeepSeek R1 for response generation. Next, in the mixing questions phase, the top-performing question sources are combined, with experiments indicating that using at most 2 high-quality sources yields the best performance, rather than mixing many sources. Following this, the question filtering step employs techniques such as difficulty-based and response length filtering to select high-quality questions, which significantly improves dataset quality. Finally, the pipeline incorporates deduplication and sampling multiple answers per question, where deduplication reduces repetition and multiple answer sampling enhances answer diversity, ultimately leading to the construction of the openthoughts 3:1.2M dataset, which contains 1.2 million carefully curated question-answer pairs across math, code, and science domains.
Can you provide a simple illustrative example of how the openthoughts data curation methodology impacts model performance, specifically using a specific dataset and reasoning task?
The openthoughts data curation methodology significantly impacts model performance, as illustrated by the openthoughts 2:1M dataset in the math reasoning task. This dataset, which incorporates 600K verified samples from OpenR1 Math and 200K unverified samples, leads to a state-of-the-art model that outperforms the R1 Distill 32B model by 6% on the AMY 25 benchmark. The methodology emphasizes the importance of high-quality question sourcing and filtering, where difficulty-based filtering and response length filtering were found to enhance dataset quality, resulting in an average performance improvement of 4% and 6% for math and code, respectively. By systematically exploring various data strategies and focusing on the best-performing sources, openthoughts demonstrates that careful curation can yield substantial gains in reasoning capabilities across benchmarks. This approach ultimately culminated in the development of OpenThinker 3-7B, which achieved the highest scores on multiple reasoning tasks, showcasing the effectiveness of the openthoughts pipeline.
What are the theoretical or practical advantages of the data curation techniques employed in openthoughts compared to existing methods in terms of reasoning performance?
The openthoughts project employs several innovative data curation techniques that provide both theoretical and practical advantages over existing methods. Firstly, the project emphasizes the importance of high-quality question sourcing, utilizing a mix of fully synthetic, semi-synthetic, and non-synthetic questions, which allows for a diverse yet high-quality dataset. Secondly, the mixing strategy reveals that combining only the top-performing sources, rather than a larger number of diverse sources, significantly enhances downstream performance, as evidenced by a 5% accuracy increase when using just 2 high-quality sources for code questions. Additionally, The project implements effective filtering methods, such as difficulty-based and response length filtering, which have shown to improve dataset quality by 4% and 6% over random filtering baselines for math and code, respectively. Finally, the empirical investigation into deduplication and sampling multiple answers per question demonstrates that optimizing for answer diversity can yield better reasoning performance, a strategy that contrasts with traditional methods that may prioritize question diversity. Overall, these techniques collectively contribute to the development of a state-of-the-art reasoning model, OpenThinker 3-7b, which outperforms previous models by a significant margin.
How did the authors validate the effectiveness of their method? Describe the experimental design, datasets used for testing, and the performance metrics that were evaluated.
The authors validated the effectiveness of their method through a systematic experimental design that involved over 1,000 ablation experiments across 3 domains: math, code, and science. They generated datasets of 31,600 question-answer pairs for each data strategy and fine-tuned the Quen 2, 5-7b instruct model on these datasets. The performance was evaluated using a set of reasoning benchmarks, including AMY 24, AMC 23, Math 500 for math, Codello Codeforces and Live Codebench for code, and GPQA Diamond and JEE Bench for science. The primary performance metric was the average score across these benchmarks, which allowed the authors to compare the effectiveness of different data curation strategies. The results indicated that their final model, OpenThinker 3-7b, outperformed previous models by significant margins, demonstrating the success of their data curation techniques.
What notable results did the OpenThoughts project achieve in comparison to existing models like R1-7b? And what do these results indicate about the performance of the proposed method?
The OpenThoughts project achieved significant advancements with the resulting model, OpenThinker 3-7b, outperforming the R1-7b model by an average of 12.4 points across 12 reasoning tasks. This performance was attributed to the systematic exploration of data curation techniques and the scaling of the dataset to 1.2 million samples, which included 850,000 math, 250,000 code, and 100,000 science data points. The findings indicate that the quality and scale of the curated dataset are critical levers for enhancing reasoning capabilities, as OpenThinker 3-7b also surpassed the next best open data model, Nemotron Nano-8b, by 2.1 points. Furthermore, the project demonstrated that models with superior performance do not always correlate with being better teachers, as evidenced by QWQ32b being a stronger teacher than DeepSeek R1, despite lower benchmark scores. Overall, these results underscore the effectiveness of the OpenThoughts methodology in producing high-performing reasoning models through innovative data curation strategies.